Okay, yeah. So a couple of weeks ago, I was going to the medical lab, and they took a blood sample and analyzed it. And there was this amazing new technology, so they said I could get my results over the internet. And what they gave me was actually a sheet where, with the URL where I could log in and check my results. And what was on the sheet was a small screenshot of the well-known pop-up window where it says, are you, the certificate of the website is invalid, do you want to accept it? And below it was the caption, if you're asked if you want to accept the certificate, please click accept or OK, depending on your browser. So if the medical examiner tells you to accept invalid certificates, maybe the least of your worries are your printers. But still, actually, we think it's a pretty interesting topic because printers print confidential information all the time, and if an attacker is able to bug a printer once and take it over, he can gain continued access to this information. So maybe a little background about me. I'm working as a security researcher and penetration tester for the Austrian company Seconsult. We do some kind of stuff like penetration testing and consulting for organizational security stuff, ISO 27001 and things like that. I'm not going to bore you really with this slide, so let's get straight to the talk. What is the talk about it all? So at first, we're going to have a look, why are printers interesting at all to an attacker? So what can an attacker gain by attacking the printers? Then we're going to show you, once you have downloaded the firmware of a printer, and luckily quite a number of firmwares for printers are online freely available, so most of those vendors have a web page where you can download the firmware. So once you have downloaded the firmware, what can you do with it and how to extract it and analyze it and get to the data that is actually behind the firmware. Then we are going to show you a zero-day vulnerability. This is the first time this vulnerability is disclosed. Actually, we strongly believe in responsible disclosure, so of course we let the vendor know it. And Xerox was really cool about it. They had one of the most professional security incident response we've ever seen. And they actually even saw the slides and allowed us to present them, so that's really cool. After those vulnerabilities, I'm going to show you some further analysis. And actually in our lab, we succeeded in emulating a printer using QEMU. And we were able to do some black box fuzzing testing with a printer where you do not own the actual hardware, but which just runs in the emulator. Finally, we'll do some conclusions. Okay, so why are printers interesting to attackers at all? Printers have some obvious disadvantages. So the first thing is printers are rarely connected to the internet. So mostly you have to be on the local network to get access to the printers. But the theme of this DeepSec is this industrial espionage. And for someone who directly targeted attacks a company, how hard can it get to, how hard can it be to get access to the local area network? So all he has to do is put on some blueware and a toolbox and say, okay, there is the closet dripping in the 4th floor and I'm here to repair that. And somewhere on the way, he will definitely find a conference room where he can plug in his laptop. Actually, probably nowadays, it's not even strange if the plumber has a laptop with him, because everything IT is everywhere nowadays. And even so, if you have some printer firmware analyzed and you do some Google search for words that come up in the firmware, it's really surprising how many printers actually are connected to the internet. So for almost all brands of printers we analyzed, we also found printers that were connected directly to the internet, and that where Google found the administrative interface. The second thing, which is somewhat of a disadvantage for an attacker, is that discovering vulnerabilities in printers is more or less hard work, or so it seems. So the problem for an attacker is that in many cases formerly he used to have to own the hardware. And some of these printers can be pretty expensive. So you can pay up to 5,000 euros for a single piece of printer if it's a large one. And buying such a printer just to find vulnerabilities and attack your target is not very feasible. So for this also, firmware analysis is good because you don't need to own the printer, the hardware, to be able to do security analysis. On the other hand, there are also quite a number of advantages that makes it easier for an attacker to own the printers. The first one is printers do not have virus scanners installed. So whatever vulnerability you find, normally you can just take your usual shell code from Metasploit and no one is going to stop you from ejecting it if you found a buffer overflow. The second thing is the printers are not covered by the patch management process in many companies. I don't know, has any one of you patched a printer in the last 6 months? Yeah, we have 2. Was this for security reasons or just because something was not working? Security? No. Okay. So yeah. If someone is patching his printers, mostly it's because the support hotlines tell them they have to patch them in order to get some stuff working. So if you succeed in finding a vulnerability in a printer, chances are it's going to work over years, because unless something is broken, nobody's going to install the manufacturer updates. Another thing is many companies use a single brand for all their printers. So companies usually tend to have tons of printers, at least one in each building stage. So if you find a single vulnerability in one printer they use, chances are you can use the same vulnerabilities on most of the other printers. Also, confidential information is sent to printers all the time. For some reasons, many people even believe that information on paper is more secure than information stored digitally, which actually is true in some cases. But if your printer has been owned by an attacker, that doesn't count any longer, and it's intercepted on the way to the printer. Yeah, like I said, owning and bugging a printer guarantees continued access to company information, and also even information that was printed before the attacker was able to take over the printer. Pretty much all printers or all larger printers nowadays have hard disks in them, where they temporarily store information if it's too large for the memory. And you would probably be able to get this information from the hard disk even if it was printed some weeks or months before the actual attack. Okay, so regarding firmware, there are 2 main attack vectors regarding printers. The first attack vector is to backdoor the firmware. So for this, you just modify the firmware and inject malicious code. So you download the firmware, extract it, plant some new binaries or plant some new code, and get the administrator to install the backdoored firmware, which is pretty hard. You have to be pretty close to the administrator to get him to install the backdoored firmware. Also, many vendors nowadays digitally sign their firmware upgrades. So if it's digitally signed, this is really hard to get rid of this signature check. On the other hand, it's pretty easy to plant the exploit code, and the backdooring of the firmware itself is not that hard. So the second attack vector is to find a vulnerability in a printer that can be exploited either locally or over the network. Printers nowadays have so many network connections open, so there are so many ways to access a printer. Pretty much all of them have a web interface, but many of them also have SMP server running on them where people can just copy over a normal network, share their files, and they are printed. And so in many cases, it's not that hard to find a vulnerability that can be exploited over the network. So the disadvantage is, of course, you need to find that vulnerability. And if you look for vulnerabilities in printers, you are in many cases not finding very much, especially not well-hidden vulnerabilities, because most of those vulnerabilities actually have been found through the web interface, where an attacker has succeeded in finding some kind of command injection into the printer through the web interface and used this access to the printer to find further vulnerabilities. So the focus of this talk is mainly on attack vector number 2. So how to use the firmware to find vulnerabilities in printers. Using the firmware makes it a lot easier to find such vulnerabilities. The firmware also, as I already said, is very often available through a web page. And as we will see in later slides, many of these firmwares can be extracted and allow access to the file system of the printer. So as I said, nowadays most printers have hard disks, so actually there are quite a number of printers which are running on Linux, so it's rather easy. So in some instances the printer can even be emulated, and all the binaries that are on there can be emulated and checked for vulnerabilities using fuzzing or gray box techniques. And the main advantage of using the firmware is that you don't have to own the hardware. So you can just, if you know some companies using this or that printer, just go to the vendor page, download the firmware. No need to go to some store and buy the actual printer. So part of the research still can be used for attack vector number 1, 2. For example, we will see in the later slides how those images can be extracted, or how some of these images can be extracted. And using the extracted firmware images, it's a lot easier to plant malicious code in there. Okay, so next section will be I downloaded the firmware of a printer, what now? Well, the firmware contains an image of the printer's hard disk, as well as images for some kind of other memory which is in the printer. Printers very seldomly consist of only one component. So what you have from vendors is you get one firmware, but in fact this is just a packed file which contains firmwares for all these components. So you have a firmware for the fax machine that is in the printer. You have a firmware that is for the mailbox which might be in the printer, and you have the main firmware which runs the printer in itself. So if you can gain access to the file system, what can you do with this? So for example, there are lots of configuration files which you could try to analyze and see if there are any vulnerabilities. As I said, most printers have web scripts or web interfaces. Those web interfaces can be analyzed. You have or you even might have the web interface in some scripting language like PHP, where you can see the actual source code, and it's a lot easier to find those vulnerabilities through the source code than through black box mechanisms. Also, you can look for default or support accounts. There's quite a number of default accounts actually we found in firmware. So some support accounts where an administrator might log in, and some vendor default passwords that is set in all the printers, and you can use that, for example, to log in through the console. And again, you can further investigate vulnerabilities by emulating the processor architecture and running the binaries in an emulator. So the first firmware image I'm going to show you is the one of the Xerox Work Center. this printer actually is running on Linux. And when you download the firmware, it's probably pretty small, but you don't need to read that. That's just the hex editor. What you see, it's actually a PostScript files. Most printer vendors do that they pack all the firmware in some kind of PostScript file or printer job language file. And this is the one file that is sent to the printer to upgrade the firmware. After the initial PostScript header, you have an embedded file, and you find all these kinds of magic numbers. Like, for example, 1F8B is a very common magic number, which we'll see on the next slides. So also interesting, maybe for attack vector number 1, is that here it says extraction criteria upgrade extract.sh with a path. So this is obviously just some shell script which runs. So an attacker which is able to plant some backdoor firmware might be able to change the command here and run some malicious code. However, as you can see here, there is a signature. So the firmware upgrade is digitally signed, though since we do not actually own the printer hardware, we were not able to find out if the complete file is signed or if just the compressed actual firmware upgrade, which starts below here after the PostScript header, is signed only. So when you are analyzing firmware or some unknown file format in general, magic numbers are always really useful. There are quite a number of magic numbers, and especially since most of these firmware images are compressed, those are especially interesting. And most compression formats have their own magic numbers. So for example, gzip has 1F8B, bzip has 425A, there's a magic number for compress, those are the .set archives. Zip has a magic number, and also setlib. So since on the last slide we saw the magic number was 1F8B, so obviously it's just a gzipped file with a PostScript header, Xerox firmware image. Okay, so this actually worked. We just had to get rid of the PostScript header up to the magic number and use gzip to uncompress the Xerox image, and again we saw a new file, and again with a magic number called US-tar, which indicates that it's nothing but a tar file, which can be extracted again. And in this tar file, there were all types of different firmwares. For example, you have a bootloader, you have the bootstrap code, you have the firmware for the fax machine that is in the printer. And the most interesting and by far the largest file with 96 megabytes is ECN and some number. And if you extract that file, you find the complete file system of the printer. You can see that it's running Linux, which actually isn't documented anywhere for some reason. And you have everything you could need. You have the boot directory, you have the binaries directory, you have all the scripts that run when the printer is booted. You even have the etc shadow file with the root password, which seems to be the same on all Xerox machines of this series. Due to time constraints, we were not able to actually crack this, but it should not be too much of a problem. So if you have a couple of weeks, you can easily probably crack the root password and get root access on all of these Xerox machines. Additionally, this is also really small, but it's a screenshot of the web interface. And you can see below here quite a number of PHP files. So the web interface for the Xerox printer is written actually in PHP. And some libraries which are loaded into the Apache. It runs under Apache. So this is nothing but actually a normal PC. Even the architecture, it's an i3-86 machine, so nothing uncommon about that. So we'll have a look at two other firmware images, which are a little bit harder to extract. For example, we analyzed one printer from Samsung. The first problem is that when you download the firmware image, you get just an executable, so just an exe file. And if you start the exe file, it will ask you for the IP address of the printer and will try to online upgrade the printer. So this is pretty trivial to find the actual firmware using FileMon or some similar software that shows what disk activity is going on from some program. We found that the executable creates the file clx some number.hd, which is the hardware content of the printer. This file again has a similar header. This time it's not a PostScript file, but a PYGL file, so which is short for printer job language, and it's something proprietary by Samsung, how they communicate with their printers. So again, this is an unknown file format, and what we found out that those 4 bytes you're seeing here seem very much like an offset, or actually a length. So what this is the length of the file that follows. So followed by file name. So through this information, we were able to extract again all the files that were in the firmware. Again, different firmwares for different components. You have Lily yx.bin. You have some ROM files, some more bin files, which are again firmware for different components of the printers. The largest file by far is Lily vx.bin, and if you have a look at the contents, unfortunately this time there is no magic number, and the contents doesn't seem to make a lot of sense. It's just gibberish. So what we were thinking was that either it is encrypted or it is compressed. So the easiest way to find out which of both it is to get a byte frequency, because if the image is encrypted, the byte frequency should be pretty equal. So there shouldn't be some kind of changes in byte frequency over bytes. What we did get was this curve. So obviously it is not a straight line like you would expect if it was encrypted, and it seems to be compressed. So this is actually the typical byte frequency you can find when you see something that is encrypted by some Huffman algorithm. You will also have, you will always have these spikes here. And if you see something like that in byte frequency, it's very, very likely that it's compressed using some Huffman algorithm. And one small hint, setlib is very, very common in firmware because it's available for almost all architectures and is freely available. So setlib is very common, and the first guess would be that it's setlib. So unfortunately, setlib has a number of different options. So it can have different block sizes, it can have different window sizes. This is some really trivial Perl script which does nothing but check out different window sizes and different block sizes, and also different offsets. So maybe this has some not compressed header, and the script skips the first byte, then it skips the second byte, then it skips the third byte, and so on, to find out if anything is compressed with setlib in the file. Actually, this worked, and in all the firmwares where this worked, the window size was 15 and the block size was 1024. So this seems to be really common, and this would be the first guess. as I said, this works to extract the firmware image. The problem with this firmware image, however, was that there is this real-time operating system by Wind River called VxWorks, and there is practically no information or documentation about this operating system available. So while we were able to actually get to the code, they seem to use ELF binaries. So using reverse engineering techniques, it would have been able, we would probably have been able to see what the firmware does, but lacking experience with VxWorks, that's how far we got. What else we did find with the Samsung printer was that at the very end of the firmware image, there was another file which didn't have a name, which was an HTML file, large HTML file, and a Java archive, which seems to be, or which is the web interface of the printer. And it was able to run the web interface of the printer on a normal machine. And since the Java archive is executed on the client computer, not on the printer anyway, with all clients. So for legal reasons, we did not decompile the jar file, but an attacker, of course, would not be hindered by any legal reasons. So he would probably analyze the jar file and have a look what it does. What we did find out through a simple network sniffer was that the jar file does communicate over SNMP with the printer, and all the settings are just set over SNMP. Of course, this is all completely unencrypted, and if the community string can be sniffed by an attacker, which is also a default community string, he can do pretty much anything. Even upload files to the printer, which are then printed. So maybe we do not own the hardware, and in this case, we were not able to emulate it. But maybe there are also some vulnerabilities where an attacker can upload corrupted files. Okay, and then the last firmware image which we had a look was an HP machine, CM8000, which is a really interesting printer because it's running on Windows XP embedded, which you can see on the first glance if you have to download the firmware, because it's 1.3 gigabyte big. So that's really huge. It took eternally to download just the firmware. If you have a look again at the firmware interface, and this was quite hard from a hex editor to open the 1.3 gigabyte file, you see a FAT header below here. So it's just a FAT file system which contains a number of files. It contains some PAC files, some EFI files. One of those PAC files is probably Windows XP because it's 1.1 gigabyte large. What is really interesting about this printer is that it is compliant to the UEFI standard or specification. This is short for Unified Extensible Firmware Specification that has been released by Intel. And this is actually some good progress because they are trying to make a standard for how firmware is installed onto embedded devices. And also they specify how those binary works. The specification is freely available from their website, tianocore.org. Unfortunately, it's really huge, like 2,000 pages or something like that. But what is also amazing about the UEFI specification is that Intel provides a complete open source implementation, also at tianocore.org, and a development kit, EFI development kit. And this EFI development kit contains an emulator for .EFI files. So all those EFI files you can see here are nothing but executables. They are very similar to exe or DLL files. They also use the PE file format. And using the emulator, this binary here called pacdump.efi can run. So pacdump.efi from the name really sounds like it might be able to extract all those pack files that can be found in the firmware. So using the emulator, which is a little hard to build because it's only available in source code, there are no binaries, and it requires a special version of Visual Studio to get running. But once you have it compiled, it runs really nice, and you can start it. You have different like hard disks in here, and you can just run the EFI files in the emulator, and calling pacdump EFI on one of those pack files shows you exactly the file offset, and all the items pack files seem to be, they are proprietary formats from HP, and they contain different kinds of files, and pacdump shows you the offsets and the sizes sorry, of all the parts in the file. So using the information from pacdump again, we were able to extract the large pack file, and what was in there were SDI files. And SDI again is short for System Development Image, and is nothing but an image format specified by Microsoft, which is used for embedded devices and also for the boot disk. So with the Windows embedded tools, there is a utility Microsoft provides called SDI Manager.wsf, and you can call this with the /dump command to get, again, to see what parts are in the SDI file and extract those parts. And the part in turn, now finally we're getting somewhere, is the NTFS image of the final file system of the printer. So it's just like normal Windows XP. You have your documents and settings directory, you have your program files, you have your Windows directory, you have, of course, the SAM files containing the default accounts you can find in there, and things like that. Okay, so that's it for how to extract firmware images. Those were just 3 examples we more or less randomly took. We also had a look at quite a number of different printers. And in the end, it's mostly the same for all these printers. Unfortunately, like the Samsung printer, many of those run pretty obscure operating systems, real-time operating systems with very little documentation is available, like Lynx, for example, which is also similar to VxWorks. What I'm going to talk about now is our 2 zero-day vulnerabilities we discovered in the Xerox Work Center. They're actually not very spectacular. They're just vulnerabilities we found in the web interface. Our main focus was not to discover vulnerabilities in the printers, but rather how to analyze the printers. But those were so obvious that we couldn't really help finding them. And again, Xerox was really cool about this and had one of the most professional, definitely, incident responses that we've ever come across. So the first vulnerability is an authentication circumvention vulnerabilities. Oh, what I forgot to mention, by the way, Xerox should have released by now a patch for these vulnerabilities. So they are going to upload it to their webpage. And if you're using this printer, you can go to xerox.com and download the patch and install it on your printer, which hopefully you do. So in order to use the Xerox Work Center web interface, there are some pages which are available to the public, and most of the web pages, or the most interesting, at least for an attacker, are protected by authentication. So like the root account for the web interface is called SA for System Administrator, And in order to do real stuff and change settings on the printer, you need to be logged in as SA. So now how Xerox enforces this authentication is if you are not authenticated, and they check this by a cookie, they redirect you to the login page. And the way they do it in PHP is they call the header file, the header call with an location argument. And what this does is it sends a redirect header with the location, but this is copied from the PHP documentation. What is really vital is the exit call afterwards, because if you do not call exit after the header, the function doesn't really influence the calls of the script, but rather just changes the header, and the rest of the script runs anyway. So you really, after calling header, you should really call the exit, because otherwise the rest of the script still runs. The funny thing is, if a user is logged in but not system administrator, exit is called. If the user is not logged in at all, it is not called. So it's better in this case to be not logged in at all than being logged in as anyone on the system. So this can really easily be exploited, for example, with the burp proxy. All you have to do is in the response header, change the HTTP 1.1.302 found, which redirects the browser to HTTP 101.200 1.1.200 OK. And from now on, you can just use the web page in your browser, and you will see the same as if you were authenticated. Actually, you are authenticated, and you can do all the changes on the settings and whatever you prefer. We're fully aware that this kind of vulnerability can always be found. So there is an Austrian standard, if you're interested, A7700, which is a standard for how to write secure web applications. And you can also certify a web application after this standard. It's based on the OWASP guide. And in such a review, such a vulnerability would definitely be found. The next vulnerability, or the second vulnerability we discovered, was really fun because it seems like and deliberately placed backdoor. So if you see this directory listing here, does any file strike you as strange? There you have the file yougotit.php, which is something we did not plant there, but is actually in the original Xerox firmware image. So what this script does is the printer has some mailbox functionality, and if you want to access mailbox of a user, it can be protected using a password. So normally, if you want to see the mailbox, you have to know the password. However, if you call the script and give it the folder name of the mailbox you want to see as an argument, it sets the right cookie in order to give you authentication. So there can't be a DeepSec talk without a lolcat, so I just had to place that there. Okay. So much for the Xerox vulnerabilities. We will definitely post an advisory afterwards, but we wanted to wait until the talk. So now to the final part of the presentation, emulating a printer. In case of the Xerox Work Center printer, we actually have the complete file system, including the Linux kernel and everything we need to get the thing running in an emulator. So if we were able to start the system or to emulate the system, we could do a lot more in-depth testing than if we only have the firmware image, and we do not need to own the printer hardware for that. So as an emulator, we chose QEMU because it supports many architectures, though, as I said, with Xerox, this is not even required. You could probably also use VMware to emulate this printer because it runs on x86. So there's some small preparation work required to get it running. First, you need to create an image, format it as x3 file system, mount it on loopback, copy the file system onto the image. Now, one minor problem is that /def is empty. Of course, the devices are not there in the image. So in order to boot it, you need at least dev null and dev console. And those two devices can be easily created using make not. One problem that really cost us a lot of time was when initially we were booting the image, we always got an error message, could not open initial console. And after some long hours of searching, we found out that the symbolic links for the libraries are not correct in the firmware image. So you need to run ldconfig in order to make sure the symbolic links to the libraries are correctly created. Now, after you did this, you can just call QEMU with the right arguments. You need to give it the kernel, which is on the file system. You need to give it the image as primary hard disk, and you need to say what is the root file system. And this really works like a charm. You can start the printer in the emulator. As I said, we were not able to crack the root password quickly, so we just modified the shadow file on the image and changed the root password. So using our known root password, we could easily log in. And pretty much you can use this printer just like the normal printer. It probably will never actually print stuff, but apart from that, you can do most of the things you could do with the real printer. Okay, so some further results. By editing some symlinks, we even were able to get the web interface running, and it did have some problems because there is, in most embedded devices, something called non-volatile RAM. This is a memory where the embedded device stores all its settings. And you would need a copy of this non-volatile RAM to get access to the settings. And if you have a printer, you can easily copy this part of the memory and use it in your emulator. So in some instances, it might be better not to emulate the complete system, but rather only individual binaries. This is no longer from the Xerox printer, but rather instead from actually a Soho router, which I have at home, which crashes if you give it a URL which is longer than 10,000 characters. So we thought we'd have a look at that. And using QEMU, you can just call the binary, and there is this -g command, which you add a port to, and QEMU starts a GDB server, which can be used to debug the binary. So this is a lot easier than getting cross-compiling GDB to the embedded system, and instead you can just use the -g command of GDB or of QEMU. Okay, so then you start the HTTP server. You tell GDB to connect to localhost port 1234, which is where the GDB server is running. And you can do all your standard techniques to analyze vulnerabilities in GDB that you normally use. So you can have a look at the registers. In this case, this is the stack pointer. This is the program counter. We were not able to actually override the instruction pointer, but it seems it was like a one-off vulnerability where you could crash the router, or you could crash rather the web interface of the router, but do not inject any actual code. But still, you can have a look at the stack. What does the stack look like on the emulated binary? And you can really comfortably analyze vulnerabilities that would be otherwise really hard to analyze. Can also disassemble in GDB, just like you would call it directly and it wouldn't be emulated. Okay, so finally some conclusion. What we saw, that printers are just normal computers nowadays. They have hard disks, they have all the stuff your typical server or client has. They also have the same types of vulnerabilities, like you wouldn't expect a vulnerability in a PHP script in a printer, but they actually do have these kind of vulnerabilities. And emulation of firmware can be used to perform this kind of analysis on embedded systems, even if you do not own the actual hardware, and QEMU is really a great tool. All right, that's it. Thanks. Any questions?
If you have a question, would you raise your hand so I could bring the microphone to you for this being taped? No questions at all. I see. We're not yet running out of time. There's still 3 minutes left. Nobody has a question? So did you personally ever run across something that struck you as odd when analyzing these printer firmwares, like a specific company that approaches these issues quite differently?
I mean, we did find some strange default accounts, but lacking the hardware, we couldn't try them out where they actually work. But other than this, no. The problem is, I really like the UEFI specification because it's a standard and things are supposed to be similar across devices. And nowadays, all embedded devices just different, and they have a different way of packing the firmware. They have a different way of how the firmware is actually transported from the system of the administrator to the embedded device. So such a specification would be need for an attacker, unfortunately.
I see. Still no more other questions. In that case, thank you, Daniel.
Thanks.